That's what we have to work through here, kids. Alright, so we'd like to know what's going on in this circuit. Imagine this circuit is, you have, say, a battery in something like your car. Your car usually has like a 12-volt battery, and there's examples of this that we're going to work through. And your car battery charges a bunch of other stuff, like your cell phone battery. All right, and so maybe this is an electrical circuit for the stuff in your car. All right. Now, because we have these two batteries here, there's no easy way to go from what's presented here to an equivalent resistance, an equivalent current, a total current, and then how it splits up. But you can make some estimates here. You can say, well, probably the current's going to flow like that, and it's going to charge this battery up. And then some of the current will also flow like that, so it splits like that, and then recombines down here. So, maybe this does something, and it has to have some current flow, but that's probably what's going to happen. Now, the way I drew this is not crucial. In fact, what we did here, when we do the first step, is we identify where the current goes. And so I say I1 here goes through this part of the battery and this resistor, and it enters this junction. And then I say I2 goes up. And I1 and I2 meet, and I3 is the total. We don't know which way it flows. Maybe both these batteries power this thing over here, and that does a lot. All right, so we made a different guess here. Here we're saying that the current kind of flows like this. And then kind of also around like that. That it splits like that. So maybe it does that. That's different from this, but it's fine. Right. But the idea is that we put these labels here. And the idea is that if we think the current flows up this way, and then we get a negative number, then it means it flows the opposite direction. This is the very weird thing. Let's see if this will focus. Current has a number, and it has a direction. It's a vector. And we drew little arrows to state that it's a vector. And if we get a negative number, it points in the other direction. So, after we've drawn these arrows, the batteries we indicate plus and minus by the signs. And the resistors we indicate by which way the current flows through. So an I1 puts current plus here and minus there. I2 puts current plus here and minus there. And I3 puts plus here and minus there. Right. So that's our goal, is we outline these things like this. And now what we're going to do is, first we apply the current law, and we ask what happens at this junction. Well, I1 plus I2 come together, and you get I3 out of it. That's the wrong sheet. There we go. All right, we apply the current rule. And then there are 3 loops here. I can draw them. That's one loop in blue. Here is a loop in green. And then there is a large loop in black. There are 3 loops. So for each loop, we can come up with an equation. We pick a point, and we go around and ask, how can we order this so that we understand what's going on? All right. And so if we go plus to minus, we'll say that's a positive number. And so that's what we do here. I1 is positive and times 20 ohms. And then we go through I2 and we go negative to positive, and so that's a negative thing. And then we go through the 20 volts, and that's negative to positive. And we go through the 5, and that's positive to negative. And so that's why these signs are like this. The idea is positive to negative gets a positive sign. Negative to positive gets a negative sign. All right, so we do that for the blue loop, or the left loop. And in the right loop, we do the same thing. We pick a point, we go around, and so that's positive to negative. That's a positive number. And we get to 5 volts, but that's negative to positive, so that's negative. And then we follow I2 around, and so we get this. And that's how we're going to arrange things. If we don't know the voltage, if we don't know it's 5 volts or 20 volts, we use Ohm's law. We use I times R. And so we have a set of equations. All right? And this is the thing. We have 3 things we don't know. Everything in this top equation. But we have 4 equations to solve it. So you can solve them. And because I know the currents are going to be in amps, because I've written everything in volts and ohms, I just simplify the units. And I simplify down to a system of equations. Now, I don't know how familiar y'all are with systems of equations. This is a fairly simple one, I think, since it's overdetermined. You get 4 equations, and most of them don't involve anything very tedious. But, you know, this is the stuff you should have seen in Algebra 2 20 years ago. If you've seen it in Algebra 2 this year, I don't know. But you can solve. The idea is you solve for one variable in terms of another, and then substitute in, and eventually you get one thing that you know the value of. And here we get I2 is this minus 0.086, and the problem with that is it's negative, which means when we did the original circuit, we picked the direction wrong. We should have assumed the current goes downwards. That's okay. We just go back and fix it. Current flows downwards, and then we solve for everything else. We get our currents, and we make sure that it adds up correctly, right? Is a large amount flows into that top branch as I1, and it splits up into I2 and I3. We make sure that works out. And then we do Ohm's law, and we actually put in these I1s and I2s and the resistances to get the voltages on them, right? So all this Kerchoffs law stuff is doing is saying, we know what the potential difference needs to be, even if we don't know what it is. We know that it has to obey this rule. So we can find a set of equations for the potential that solve everything out. All right, we can find a set of equations here that we know what they, we know the voltages and we know the currents eventually, and then we can, apply Ohm's law to this circuit that we've made. So, what I want y'all to do in the practice is, here is a slightly different circuit, and you should go around and, right, just decide which way the current is going to flow around these branches, right? Just put in I1, I2, I3. There's no right or wrong way, right? I'm going to say, it probably charges up. So it's probably going to go I1, this will be I3, and this way will be I2. And so that makes sense that I1 equals I2 plus I3. All right. And so for this, go through and say, well, plus and minus in that direction. Plus and minus, plus and minus. Your batteries are already labeled. Plus and minus. If you pick different directions, it's okay. Now, I will say this, that there is a caveat. If you pick direction, say this is your circuit joint, this is your branch, you can't pick them all going into it. Right? That's no good. Right? You have to pick at least one of these going outwards. Right? You have to pick a branch that carries current away and branches that put current in. So, but otherwise, you have lots of flexibility on that. So, what I want you to do is set this up. Come up with the 4 equations. Here's one already. Or you can relabel this, redo it however you'd like. Come up with the 4 equations and then solve for the information. Alright. So, here is my cat again. And I will see you all sometime later.